This is Ritesh Srinivasan and welcome to my channel. In this video, let's look at the new model called as OPT-IML from Meta AI. So basically this is an instruction meta learning or instruction fine-tuned OPT or the Open Transformer Language Models. Okay. So first we need to know what is instruction fine-tuning. Okay. So for this, I would refer to this particular blog from Google. Talks about introducing FLAN, more generalizable language models with instruction fine tuning. Okay. So the idea over here is that instead it fine tunes the model on a large set of varied instructions. Okay. So what is instruction tuning? Let's go to that particular part. See, with zero shot or few shot prompting, you could actually, solve tasks using language models. For instance, to classify the sentiment of a movie review, a language model might be given the sentence as the movie review is, and then you can complete the language model can complete with positive or negative. So that is your zero shot or few shot prompting. Okay. Now instead of that, you can give an instruction like classify this movie review as positive or negative, or translate this sentence to Danish. Okay. So creating a data set of instructions from scratch is actually tough, right? It would take considerable amount of resources. Instead, you can use templates to transform existing data sets into an instructional format. Okay. For example, read the following and determine if the hypothesis can be inferred from the premise. You can give a premise and a hypothesis and options. Okay. So that is the template, right? So if you are tuning a natural language model on these kind of instructions, okay, and you know the target as well, so with this you can do fine tuning, then it is called as instruction fine tuning of a language model. So this OPT-IML is also an instruction fine tuned language model. So they call it as instruction meta learning. So we can see what it is at a later point of time. First we will go to a demo. Okay, so what I did was this OPT-IML is available on Hugging Face. Okay, yeah. So both OPT-IML 30 billion parameter model is also available, and the 1.3 billion parameter model is also available over here. It says that it is a set of instruction fine-tuned versions of OPT, collection of close to 2000 NLP tasks. So OPT-IML was trained on 1500 tasks. OPT-IML max has been trained on 2000 tasks. Okay. So there is this 30 billion parameter model as well. Obviously loading this parameter in a Google Collab, there are memory limitations. So I tried out with the this 1.3 billion parameters. Okay, so here they've explained how to do it. So let's go to the demo. Okay, so first you need to install transformers. Then from transformers you would import auto model for casual causal LM and auto tokenizer. Then you instantiate the model. So from pre-trained, this particular OPT-IML 1.3 billion parameters model. Okay, and also the tokenizer. Okay, so once you do that, let's try a prompt and see what kind of responses we get. Okay, so here you have prompt, what is the color of a carrot? Okay, then you pass this prompt to the tokenizer, and then you pass it to model.generate. You pass the token, basically the tokens, right? And then you decode the generated IDs. Okay, so this is the response you get. What is the color of the carrot? And then this A is actually a prompt for it's a kind of this thing what you call a special token over here. It could be answer A, different variations of that are there for the model to then generate the answer. So it says green over here. Okay, so carrots are generally orange in color, so or red in color. So this is green. That's the response we get from the model. Let's try out another. What is the color of a beetroot over here? Okay, so I have actually loaded the model and everything, and here it says red. Beets are red. Yeah, correct. Right? It could be pink, dark pink. No, they are red. Right? So this is what is the color of a beetroot. Okay. Then I tried a question which was present in this paper, right? So in this paper, in the appendices, you have their questions, right? What are the different questions they have from different benchmarks? Okay, so they have a question and an answer and different kind of prompt. So I thought I will try one question from that, which says, what Lakers legend visited LeBron James less than 24 hours before the free agent became a Laker? Okay, so that was the prompt, and if I were to run that, it gives the answer as Magic Johnson. Okay, here you need to modify this max length for the output to be generated, because when it was less, it just said magic, right? So you need to play around with this max length of the generated text. Okay, so the idea over here is, once your answer is generated like this, you can use some regular expression to extract just this answer, and you can make use of this model like a question answering system. Okay. So then we will see some other things. So one of the things which I saw in that particular list of examples over here in the, you know, zero shot examples of this particular model was, given a particular review, you can actually generate a rating for the review. Okay, so here I have given the prompt as, given the following review. Okay, I pulled out this review from Amazon. It says, this is the worst decision to move to iOS. Somebody has bought an iPhone and is not happy with it. Okay. So the prompt here is that, given the following review, your review content, and then say that, predict the associated rating from the following choices, 1 being the lowest and 5 being the highest, and then you give a rating. Okay. So that is the idea. So here I set it as rating, answer, it could be different, right? So this is zero shot. So I am running it over here. Okay, now let's see. It gives a rating of 1. Actually, this was rated 1 on Amazon. Okay. So yeah, somebody bought an iPhone 14 Pro for 1.5 lakhs and is not happy with he or she is not happy with the phone. Okay. Now let's take another review. Here, the review is positive. The iPhone 14 Pro is a game changer. So basically, you can do zero shot review classification, right, into some kind of ratings. So let's try out this. Just by having this prompt, give the following review, and towards the end of the review, you also have predict the associated rating from the following choices. Let's try it out. Okay. So this one, it gives a rating of 5. This was a 5-star rated review. Okay. But then it is not always accurate. Okay. For example, here in this review, it says that Nokia G60 is way better than this iPhone 14 Pro or whatever. It was a review of iPhone 14 Pro. Okay. And when I tried this, it gives a rating of 5, whereas it was a rating of 1 or 2. Okay. So yeah, in zero shot settings, this model may not be very accurate. Again, this is a 1.3 billion parameter model, not the 30 billion parameter model of OPT. The 30 billion OPT-IML may perform better. Okay. Right. So that was the output of this particular thing. Okay. Then I wanted to try summarization, because there were some examples of summarization over here. So I wanted to say, write the highlights for below article output, because this was an example present in their paper. But when I tried this particular prompt, I did not get any summary. So it's running. I did not get any summary. Okay. So I tried some variations of this prompt, but yeah, it did not work with this model. Okay. Then this is some kind of a task. Okay. So here it is like, you are given this particular array list and you are given instructions like remove all duplicates. If nothing is present over here, then give out an empty list. Okay. And then you have this A over here for your answer. Okay. Now let's try out this. So from this array, basically it has to only give the output as those digits which don't have duplicates. Okay. So here it performs very well. It pulls out these numbers 6, 4, 1, right? And their duplicates are not present in this particular array. Okay, maybe what I will do is, for a change, let me see this. I will change the input a little bit. And then see what happens. Basically 6 should be out of the list now. Yeah, 0, 4, 1. Even though 0 duplicates are present. You saw that, right? In the previous case, it gave 6, 4, 1. It did not give 0. But I just removed 6 over here. I just added 6 over here. Still duplicates of 0 are there. It still gives that as part of the output. So not very accurate in terms of this thing, but this is a smaller model. Okay. Another example which I saw was this. In this task, you'll be given a list of integers. Find the numbers which are divisible by 0. If every integer in the input list is divisible by 3, then an empty list should be returned. Okay, otherwise, you should remove all the integers that are divisible by 3 from the list. Okay, so minus 90, yeah, some numbers over here are divisible by 3, right? So let's see what happens. List. So basically, you are removing the numbers which are divisible by 3 over here. Okay. So if you see, it doesn't do it. Yeah, so some of these things, there are issues, okay, because being of a smaller model could be, maybe there are issues with the larger model as well. We don't know, okay, until we try it. So here is another prompt which says that in this task, you are given a text of a news article and corresponding headline of an article. Your task is to give label match. Okay, if the headline corresponds to the article, then you have to match it. So here is the article. Mike Sonne coached Pune FC, bounced back with the win, and headline says bounce back to. So the answer is match over here, right? Let's try out what the model gives. So the model over here gives it as match. Okay. I tried another example where I said in the article is Chennai Kings lost the match against RCB. Virat Kohli hit a fantastic century. A fictional article, right? And a fictional headline saying RCB bounce backs to winning ways. Okay. So here it's a match according to me, right? Let's see what the model gives. So the model gives us no over here. So this is kind of, yeah, again, unexpected answer over here. I was expecting it to be a match. So sometimes it works, sometimes it fails. Now we can also try out something like, classifying comments as toxic or not toxic. Okay. So here I have actually a toxic comment. Okay. Which is about, okay, let's, let's bring this bottom because the comments were different. Okay. Here I have a toxic comment. You people should leave the country, go to hell. You will see this frequently on Twitter, right? So I tried out this prompt, okay, and I said, is the following comment toxic, right? Let's see what is the answer over here. So it says yes, okay. But then I also have some toxic comments pulled out from some databases, okay, like this. I'm socket papa sending personal abuse. So actually it's a toxic comment, but it says no. So that's also possible, okay. So this being a generative model, some of these classifications and other things may not be proper, but you can do a lot of these kind of few short tasks using OPT-IML. Okay. So I'll be covering the OPT-IML in detail in another video. So you can look at that video for the details of OPT-IML. But this was a demo of OPT-IML and its capabilities. I will be sharing this particular notebook in the description of the video. Also the link to the Hugging Face page of model card of OPT-IML and the paper. You can have a look at that. If you find this video useful, please like, share, subscribe to the channel. See you in another video.